Howdy! This is your friendly neighborhood physics teacher here, and you're on your last review video. Woo! Now, if you're starting with this one, you have about 6, 7, I don't know how many videos to go back to. The first one is your torque video. In the torque video, it will go through all what to expect the day of the final and during the final and everything. So definitely make sure, even though if you think you understand torque, go ahead and watch that video. But you have the torque video, the momentum video, the 2D motion video. You have the wave video, nuclear video, electricity video, and now you have the circuit video. So this beginning part is just the beginning of your review. So the first column is your variable, which goes into the equation. Next is your unit, which goes after the number, and of course your equation. So current is represented with an I. The unit for current is amps. Voltage is represented with a V, and your unit is volts, and your equation is V equals IR. You have resistance, which is represented with an R. It's measured in omega, which is your ohms. And there's actually one more I need to add, power. So power is represented with a P and watts, and it does have an equation, P equals V times I. Now, for your resistance, there's actually two resistance equations. You have your total resistance for parallel and your total resistance for series. So to know that your total resistance for parallel, just TRP, again, that's measured in ohms, and that is 1 over your total resistance equals 1 over resistant 1, 1 over resistant 2, plus 1 over resistance 3, and just continues. So your total resistance in a series just has a little s. It's still measured in ohms, and that'd be your total resistance in series. You just add up your resistance, and you add up as many as you have. Now in this area right here, I'm going to do a T-chart telling the difference between series and parallel. There should be only one R. Try that again. Parallel circuits. So for series circuit, your resistance are just added up like I stated before. And you just add up as many as you have. Your voltage, you just add up. Your current, this is the thing, your total current is equal to all your other currents. Current is equal. Voltage you add up. Current is equal. And your power you just add up. For parallel, your resistance is 1 over. Plus 1 over resistance 2 plus 1 over resistance 3. Another thing is, for your total should be bigger than all your other resistance. For parallel, your total should be smaller than any of your other resistors. So that'd be a good thing to check. So if your total resistance for a parallel is smaller than your other resistors, you're good. If your total resistance is bigger for a series, you're good. For voltage is just the same. Your current, you add up. So these are just flipped. Your power just stays the same. You just add up. Give me a little bit more room. I was wanting a little bit more room. Try it again. There we go. A little bit more room. We're just going to ignore those numbers for right now. So for a series, you'll know it's a series because it's one big loop. You'll know it's a parallel because there's several loops. And the reason your current is the same is because there's one loop, there's one current. Current is different because you have several pathways. Several pathways you can take. So just a quick little thing to look at. Now, going into the questions. What is the total resistance of a series if we have resistors 2 ohms, 7 ohms, and 4 ohms? So if we're doing the guess method, R1 would be 2 ohms, R2 would be 7 ohms, R3 would be 4 ohms, and R unknown is your total resistance in a series circuit. So our equation would be, you just add them up. R1 plus R2 plus R3. So it'd just be 2 plus 7 plus 4 would give you our total. So you just plug that in your handy calculator. This you can just use the calculator on Schoology because you're just adding 2 plus 7 plus 4 and you get 13 ohms. Now I stated over here, if you're in a series, your total resistance should be bigger than all your other resistors. So is 13 bigger than 2, 7, and 4? Good. There we go. So now for a parallel. Again, givens, exact same givens. R1 is going to be 2 ohms. R2 is going to be 7 ohms. R3 is going to be 4 ohms. Our unknown is going to be our total in parallel, and that is also going to be ohms. But our equation is going to be a little different. That's when we're going to do 1 over our total equals 1 over R1 plus 1 over R2 plus over R3. Because that means we're going to do 1 over 2 plus 1 over 7 plus 1 over 4. And my best suggestion to make sure you do it right is I would go ahead and get the fraction form or the decimal form of these. So it'd be 0.5 plus 0.14 plus 0.25. And you would go ahead and add those up. And you would get a 0.89. Now that is 1 over your total resistance. We want total resistance, not 1 over total resistance. So we need, just like our Lenz equation, we need to flip. And what we do to one side, we have to do to the other. So if we flip it, we get our total resistance for parallel to be 1 over 0.89. We plug that into our handy dandy calculator. And you get 1.12 ohms. Now I stated that for a parallel, that should be smaller than all your other resistors. So your resistors was 2, 7, and 4. Is that smaller? Yes. So you're golden. Very good. So what type of circuits are in buildings? It is a parallel. So parallel circuits are used to make buildings because of that multiple loop aspect of it. So if we want to turn off the lights or turn off the fan, we can still have our refrigerator running or our microwave running without everything else having to be running. So it says label all the letters in the circuit and what are their purpose. So let's start with, I guess, X. So X is a switch, and it's a safety mechanism. So you can be able to turn off the circuit if need be. Y is a light bulb, so it produces light. W is a resistor. Whole point of a resistor is to kind of slow down your electrons so it doesn't do a surge, so your light bulb doesn't break. Say if it only needs to take 2 electrons, but your battery is like pushing 10 out there, so that resistor kind of slows down your electrons so you don't have a surge. And Z is your battery. And your battery is what produces the voltage, what produces the energy that it gives to electrons to make the circuit work. What is a fuse? Basically, what a fuse is little pieces of metal. So if you have wire, and then it's basically like little pieces of metal. Here, we'll get a different color. Little pieces of metal that connects the wire, and if it overheats at all, the metal will melt and break, and it will it'll stop the electricity be able to move. It'll stop the current. And the reason is that so your circuit doesn't overheat. So the whole point of a fuse is to make sure it doesn't overheat. If you think about a breaker box in your house or in a building, if there's a surge, your breaker will flip, like your switch will flip. And it's basically, and if you break your breaker, your metal has melted. But that switch is there, like there's an extra oof of electricity instead of catching your house on fire or breaking every appliance in that little section. It just flips the breaker. Same thing with really expensive extension cords that have several plugs. Yeah, the reason you put your high dollar appliances on a surge protector, it's basically it has a fuse in there. If lightning strikes your house, that surge protector will break, but it will stop that electricity getting to your computer, your phone. Insert gaming system here to keeping it from breaking your expensive appliances. So next one light goes out and all the lights go out. What type of circuit is this? This will end up being your series circuit. And it's because of that one loop aspect. If you break that connection for one of the loops, so if we have a battery here, resistor. So if you break that connection, at any point in time, those electrons can't move. So no light bulb is out. So again, that's why it's not very efficient. So one light goes out, but none of the lights go out. That is dealing with your parallel. It has multiple pathways the electrons can take. So let's say this one breaks, the electrons still have 2 pathways to work. So that's going back to your house. If you you can turn off, say you're cold, but you need the light, you can turn off your fan and leave your light on, and everything still works. Versus if it was in a series, you would have to have your light on, your fan on, everything else on that would be in your bedroom. So next one, the picture kind of didn't go through, so I'm going to make it real quick. So it says, what is the resistor? So we have the voltage of the battery. So I'm just wondering where you're at. So you have a battery. You had an amp meter right here. And you had a resistor right there. So it says for the battery was 10 volts. Your amp meter read 14 amps. And then you had a resistor there. And it says, what is the resistor? So we can make a little chart if you wish. Voltage, current. And you only have one resistor. So if you have voltage, current, resistor, or power, and you have one resistor and total. So let's write down. So we know our total voltage because the battery tells us our total voltage. So that's 10. And this amp meter is telling us our total current. And we need to know our resistor. So our current is the same because our current is the same for a series, even though this is not, it only has one. Our voltage, there's only one there, so our voltage ends up being the same because there's not two resistors to pull from. So therefore, guess what? Our resistor is going to be the same. So we can just use our V equals IR equation. V is 10, I is 14. We're looking for R. It's being multiplied. The opposite of multiply is divide. What we do to one side, we got to do the other. So you just use your handy calculator, and you can just use the calculator on Schoology for this. You just do 10 divided by 14, and you get that your resistor is 0.71 ohms. There you go. There's your answer. So you didn't have to do the chart. I was just showing you how the chart works. What is the voltage of the battery? Again, the picture didn't turn out. So let's try here. So we have a battery with 3 resistors. And then it did have an amp meter. So we don't know the voltage of the battery, but we know first resistor is 60. Second resistor is 40. Third resistor was 20. And our amp meter read 0.3 amps. Give myself some room here since I wrote it kind of big. So this one does have multiple resistors, so we can go ahead and use the chart. Didn't mean to make it so big. And voltage, current, 1, 2, 3 total. So that'd be voltage, current, resistor. If we need power, 1, 2, 3 total. So figure what our, so it doesn't matter which ones you make first, second. So we're just going to do 60, 40, 20. And it does give us our total current. And since it's a series circuit, our current is going to be the same all the way up. So there's a couple of ways of doing this. You can go ahead and find the voltage for each one and then add it up, or you can sit there and find your total resistor and then multiply. So let's do the total resistor and multiply. You know what? We're going to end up doing both. So your resistance, your total resistance for a series circuit is you just add up the number of resistors. We have 3. So it'd be 60 plus 40 plus 20 would get us our total. You can just use your Schoology calculator for that. So it would just be 120 as your total there. So your total resistance is 120. And then you can, if your voltage is I times R, your current is 0.3, your resistance is 120. Again, you can just plug that into your handy dandy calculator and you get 36 volts. Now, if you want to check to make sure you did your math right, more than welcome to. Let's get a different color to check our math. So we're going to do V equals IR for each one of these. So you're going to just do 0.3 times 60. 0.3 times, 0.3 times 60 to get 18. 0.3 times 40 to get 12. And 0.3 times 20 to get 6. And then you're just going to add up each one to make sure you get 36. And we do. Woohoo! So our answer is 36. Yay! Last question. So what is the relationship of Ohm's law? Hope you know that Ohm's law is V equals IR. So there's different types of relationships that's going on here. So let's say our voltage is increasing and our current is staying the same. So if we want our current to stay the same, that means our resistance would have to increase. And of course, you have vice versa. If it goes down, that goes down. That gives you a direct relationship. If you're looking at keeping voltage the same, as current increases, your resistance would actually have to decrease. And then vice versa, that will give you an inverse relationship. One more. If you're keeping resistance the same, as voltage increases, your current would increase. As your voltage decreases, your current would decrease. And so that would give you a direct relationship. So there we go. There's your relationships. And that is it for your circuit review. That is it for your spring final review. If you have any questions, please let Miss Heath or Miss Verona know. Hope you have a fun time reviewing and have a absolutely wonderful day. Bye!